Hey everyone, in today's video we're going to be looking at another set of algebra problems to help prepare us for pre-calculus. Let's get started. In number 1, we are asked to find the distance between 2 points, -8, -2, and 4, -8, using the distance formula. The way that I'm going to begin this problem is by assigning the 2 points x1, y1, and x2, y2. That way we can plug them into our formula. So here, d is equal to the square root, and plugging in our points, we're going to get 4 minus -8 squared plus -8 minus -2 squared. Continuing to simplify, 4 minus -8 is 12, and -8 minus -2 is -6. As you continue to simplify, 12 squared is 144, and -6 squared is 36, so 144 plus 36 would give us 180. But notice that 180 is not fully simplified, so let's continue to work on simplifying the square root of 180. Well, square root of 180 is the same as 36 times 5, and since 36 is a perfect square, this would simplify to 6 square root of 5, which is answer choice D. In problem 2, we want to consider the points on the graph and try to find the distance between the 2 points provided. Now, when you are given 2 points on the coordinate plane, one thing that we could actually do is set up a right triangle between the 2 points. The reason this might be helpful for us is because we can now use Pythagorean's theorem since we are using a right triangle. We can find the dimensions or the legs of the triangle by counting the squares. So 1, 2, 3, 4, and then 1, 2 right here. And I'll call x the distance that we're looking for. So I can now say that the two legs, 4 and 2, so 4 squared plus 2 squared, should equal the hypotenuse squared, which is x. This would give us 16 plus 4 equals x squared, which means that 20 equals x squared. Taking the square root of both sides and simplifying the square root of 20, since 20 is 4 times 5 and 4 is a perfect square, square root of 20 would simplify to 2 square root of 5. So the distance x is 2 square root of 5 units. In number 3, we want to find the midpoint between 2 points t and u. Well, let's remind ourselves of the midpoint formula. The midpoint formula says that the midpoint m is the 2 x values added together and divided by 2, and the 2 y values added together and divided by 2. So let's go ahead and assign x1, y1, x2, y2, just so we don't get mixed up. Plugging into our formula, we have -13.8 plus 7.9 divided by 2, and then we have 3.9 plus -7.6 divided by 2, and if we continue to simplify here, we would end up getting -2.95 for our x-coordinate and -1.85 for our y-coordinate. Problem number 4 is very similar, however this time they gave us the midpoint m and we want to find the coordinates, the 2 endpoints essentially. So there's a small typo here, it should say find the coordinates of t, so that m should be a t. But let's go ahead and get started. So since we know that the midpoint m is 10.5 and 17, we know that that's going to be equal to x plus 13 divided by 2, because we already know one of the x-coordinates is 13. The other x-coordinate we're looking for we'll call x, and then y plus 17 divided by 2. What this allows us to do is actually form 2 equations. We know that x plus 13 over 2 should equal 10.5, and we also know that y plus 17 over 2 should equal 17. Solving both equations, so for the equation that involves the variable x, we could multiply both sides by 2. This would give us x plus 13 equals 21, which means that x must be 8. And the equation involving y, well, we would get y plus 17 equals 34 after multiplying both sides by 2, which would tell us that y equals 17. That means that the other coordinate must be 8, 17. In number 5, we are asked to find or verify which of these answer choices is a bisector of the line segment with endpoints at the two specific points. So essentially, remember that a bisector is, or a line as a bisector, is a line that separates a line segment into two perfect halves. So let's go ahead and find the midpoint of those 2 points. So we would say that the midpoint would be negative 1.8 plus 8.2 divided by 2, comma 3.9 plus negative 1.1 divided by 2. Working through our math here, so negative 1.8 plus 8.2. That's going to give us 6.4 divided by 2 would give us 3.2. And then for our y-coordinate, 3.9 plus negative 1.1 divided by 2 would give us 1.4. So our midpoint is 3.2 comma 1.4. And we want to know which of those equations contains the point 3.2 comma 1.4. So instead of testing them all, let's just test option C. And I know that because it turns out to be the correct answer. But let's verify that that point 3.2 comma 1.4 is actually on the equation of the line, or is on the line generated by the equation 2x minus 5. So let's plug in 3.2 for x and 1.4 for y. And we can verify that 2 times 3.2 is 6.4, and 6.4 minus 5 is indeed 1.4. So we have checked it out. Number 6, so we want to find the product of a monomial times a trinomial. So essentially what we're going to do is distribute. What we need to make sure that we are careful with is that when we multiply two expressions like this, that we multiply the coefficients, but we add the exponents for variables that are the same. So negative 6x squared times negative 4x squared, that would be positive 24, x to the fourth. Negative 6x squared times negative 2x would be positive 12, x to the third. And negative 6x squared times positive 3 would be negative 18x squared. And that would be answer choice D. For problem 7, very similar, but now notice we have multiple variables. We have x and y. But the process is going to be essentially the same. We're going to multiply coefficients, and we're going to add exponents if the variables are the same. So let's go ahead and distribute 3x squared y. So 3x squared y times negative 5xy to the third, we would get negative 15. X to the third, because remember, if you don't see an exponent, it's an implied 1. So adding the 2 and the 1 together for the variable x gives us x to the third. And then y to the first, y to the third would give us y to the fourth, adding those exponents. Then for the next term, well, 3 times 2 would give us 6. We're going to have x to the third, and then y. And then for our last term, 3x squared times y to the first times negative 7 would simply be negative 21 x squared y. And that would be answer choice A. Number 8, express the area of a square with side 4g minus 1 as a trinomial written in standard form. Well, remember that the area of a square is one of the sides, since all sides are the same, squared. So we want to do 4g minus 1 to the second power. Well, recall that 4g minus 1 is simply 4g minus 1 times itself. And we have many ways to multiply an expression like this. I'm going to choose the box method of multiplication. The reason I choose the box method is because I think it's a very nice visual representation. So we are multiplying 4g minus 1 times itself, 4g minus 1. 4g times 4g would be 16g squared. 4g times negative 1 is negative 4g, and positive 1. So combining our like terms, this would give us 16g squared minus 8g plus 1, which is answer choice D. Problem 9, find the product, simplify your answer. So it's basically another multiplying problem, but notice this time we have a binomial times a trinomial. So again, I'm going to use the box method, and the reason I'm going to do this is because, oh, that's terrible. I think it gets a lot easier to use the box method when the dimensions get larger. So we have 2x minus 1, and then we have 3x squared minus 5x and 4. So 2x times 3x squared is 6x to the third. 2x times negative 5x is negative 10x to the second. 2x times 4 is 8x. 3x squared times negative 1 is negative 3x squared. Negative 1 times negative 5x is 5x. And negative 1 times 4 is negative 4. Now we can combine like terms. So notice that 10x squared is a like term with negative 3x squared. And the 8x is a like term with 5x. All other terms are not like terms. So we have 6x to the third minus 13x squared plus 13x minus 4, which is answer choice D. Number 10 asks us to factor completely, so 42g squared plus 6g. What we want to do first is we want to look for something called the greatest common factor, which is the largest factor or the largest term that is a factor of both 42g squared and 6g. Well, notice that 6 can divide both 42 and itself, so 6 would be part of our greatest common factor. Also notice that both 42g squared and 6g contain a factor of g. So I'm going to factor out the 6g, the GCF, and after factoring out a 6g, well, from 42g squared, we will have 7g remaining, and from 6g, well, we factored out the entire 6g, so we would only have 1 remaining. Notice that you could also multiply your result back out, and you should get the expression that you started with. And this is answer choice B. Number 11, factor completely. Type your answer as a product of factors with no spaces. So for number 11, I'm going to use something called the Xbox method of factoring. This is also known as the AC method of factoring and pretty much factoring by grouping as well. So the way that I'm going to start is I'm going to list my A, B, and C term. So my A term, let me get right here, let's zoom in a little bit. So my A term is going to be 5. My B term will be 23. My C term will be negative 10. So what I want to do is for this box, I want to multiply the A and the C terms together. 5 times negative 10 would be negative 50. And I want to put the B term on the bottom. So the B term is 23. So the top term was A times C. The bottom term was B. And the numbers here on the sides need to be two numbers that multiply to negative 50 but add to positive 23. Well, 25 and negative 2, because 25 times negative 2 is negative 50, but 25 plus negative 2 is positive 23. So essentially what we're going to do is we're going to take the original expression and we're going to split the middle term into these two. So instead of having a 23q, we are now going to have a 25q minus a 2q, but then we still have the minus 10 here. And we're going to take this expression and we're going to go ahead and put it into a box. This is why it's called the X box method. We have the X here where we found the 25 and the minus 2, and now we're going to take this box. And we're essentially going to do the reverse of box method multiplying. So we have 5q squared, 25q, negative 2q, and negative 10. And we want to try to ask ourselves what numbers could have created this box. Well, we can use GCFs. We can ask ourselves, what is the greatest common factor of 5q squared and 25q? Well, the greatest common factor would have been 5q. What about negative 2q and negative 10? Well, the greatest common factor could have been minus 2. What about 5q squared and negative 2q? Well, really, all they have in common is a q. And then what about 25q and negative 10? Well, the greatest common factor they have in common is a 5. So that means that our factors would have been 5q minus 2 times q plus 5. And notice that we can double check by multiplying. 5q times q is 5q squared. 5 times 5q is 25q. Negative 2 times q is negative 2q, and negative 2 times 5 is negative 10. So everything checks out here. In number 12, we want to factor completely. So when factoring, I always think it's a good idea to start with the greatest common factor. I can tell from this problem that the greatest common factor is going to be 2. So if I factor out a 2, I'm going to get 9x squared minus 25. And we now have a very special case here. This is called a difference of two squares. Notice that it's a difference, which means subtraction, and both the terms here are perfect squares. So you might ask yourself, well, what times what would give us 9x squared? Well, 3x times 3x would give us 9x squared. Similarly, 5 times 5 would give us 25. So the way that this would break down, if you have a difference of two squares, is that we would have our GCF on the outside, and these would be our factors, 3x plus 5, 3x minus 5, and that is because a difference of two squares, a squared minus b squared, is equal to a plus b times a minus b. And this is answer choice C. Number 13, solve the quadratic equation. So solve for w, w squared minus 5w minus 6 equals 0. Now, one thing that I noticed is that this is actually a pretty easy problem to factor. We could use the Xbox method if you wanted to, and let's go ahead and do that real quick. So we would have that a is equal to 1, b is equal to negative 5, and c is equal to negative 6. So a times c, we would have negative 6 on top, we'd have negative 5 on the bottom, so we want to know what multiplies to negative 6 but adds to negative 5. Well, negative 6 times 1 is negative 6, but negative 6 plus 1 is negative 5. So this would make our box w squared minus 6w plus 1w minus 6. And that would give us the terms w plus 1 and w minus 6. So our factors would be w plus 1 times w minus 6. However, notice we are not being asked to factor, we are being asked to solve for w. So what we need to do is set these factors equal to 0. And by the zero product property, which states that if two things are being multiplied together to give you a product of 0, then one or both of those two things had to be 0 to begin with. So that allows us to say, okay, well, w plus 1 could be 0, or w minus 6 could be 0. Well, this would tell us that w is equal to negative 1, and this would tell us that w is equal to positive 6. And those would be our two answers. All right, number 14 is an application problem about Taylor launching a ball off of a building, and we're given an equation, a function, to model this situation. And the question is, how many seconds will it take for the ball to reach the ground below? So let's try to model this problem here. We have this ball. It's being thrown from the top of a roof and comes down, hits the ground somewhere. And we want to know, when did it hit the ground, or how long does it take? Well, since the horizontal axis will be time and the vertical axis will be height, we are essentially looking for a root or a solution. So one thing we can do is we can try to factor this and set our roots equal to 0 and solve. So the GCF in this particular equation actually turns out to be negative 4.9. We can factor out negative 4.9, and let's see what we would get. We would have t squared, that should be a power of 2, by the way, t squared, and then 19.6 divided by negative 4.9 would give us minus 4, so minus 4t. 58.8 divided by negative 4.9 give us negative 12. And we can now go ahead and try to factor that. So it turns out if you were to try to factor this, we want to find basically two numbers that would multiply to give us negative 12, but those same two numbers would add to give us negative 4. So that would end up being t minus 6 and t plus 2. And then we could take those two factors and we could set them equal to 0. So t minus 6 equals 0. T minus 2 equals 0. Well, this would tell us that t equals 6 seconds, and this would tell us that t equals negative 2 seconds. But which one doesn't make sense? Well, when we think about it here, we can't have a negative time. So we're going to take t equals 6 seconds. Problem number 15, complete the square. Which number could replace k to create a perfect square trinomial? So essentially what we want to ask ourselves is what number could go in for k to where we could turn that trinomial into a binomial to the second power. So essentially what we're going to do is we're going to take the b term, the middle term, we're going to cut it in half and we're going to square it. So if I take negative 30, divide it by 2, and square it, that's going to give us the k term that would make this a perfect square trinomial. Well, negative 30 divided by 2 is going to be negative 15, and negative 15 to the second power is 225. And that number would be k. In number 16, we want to rewrite the quadratic equation, which is in standard form, into vertex form by completing the square. So let's go through the process of completing the square. So here we have y equals x squared plus 10x plus 23. And we want to begin by setting this equal to 0. So x squared plus 10x plus 23 equals 0. The next thing that we want to do is we want to separate the constant from the side with the variables. So we'd have x squared plus 10x equals negative 23. And notice I'm leaving a little space here because we're going to do something with this space. So if we think back to the problem we just did, number 15, we wanted to know what number could be added on here to create a perfect square trinomial. Well, let's do the same thing right here. Let's think to ourselves, what could I add right here to create a perfect square trinomial? Well, half of 10 is 5, and 5 to the second power is 25. So let's add 25 right here. However, if we add something to the left side of an equation, we must keep the balance and add that same exact thing to the right side. But now let's see what happens. X squared plus 10x plus 25, I can now rewrite this as x plus 5 to the second power. If you were to factor that, you would get x plus 5 times x plus 5. That's why perfect square trinomials are so useful. On the right side, negative 23 plus 25 would give us positive 2. Now, moving the positive 2 back over to the other side, we would have x plus 5 squared minus 2 equals 0. And this piece right here, that is what our vertex form would become. Y equals x plus 5 squared minus 2, which is answer choice D. All right, our last problem on this algebra review has us solving by completing the square. So we will follow the same exact steps in the same process, but we will use those steps to then solve the quadratic equation. So we already have the constant on the other side. Notice that the 11 is already separated from d squared plus 8d, so some of the work has been done for us. So now we need to think to ourselves, what could I add to both sides to make the left side a perfect square trinomial? Well, half of 8 is 4, and 4 squared is 16. So let's go ahead and add 16 to both sides. Rewriting the left side as a binomial to the second power, we would have d plus 4 to the second power equals 27. So at this point in the completing the square process, we can now try to solve. Let's go ahead and take the square root of both sides and see what happens here. So notice that the square root and the power of 2 will cancel. We'll have d plus 4 equals, well, the square root of 27, if I were to simplify that, would be 3 square root of 3, plus or minus 3 square root of 3. And then to solve for d, all we would need to do is subtract the 4, so we'd have d equals negative 4 plus or minus 3 times the square root of 3, which is answer choice C.